Every day, there's millions of people at the gym. Now imagine, while you're burning those extra calories, you can also generate some electricity. Our project is basically making a bike generator that we can harness the energy and put it back into the gym's grid.
So as she's biking, the DC voltage and current coming from the motor, we're converting that into AC. So it has a fixed peak, and this is the DC voltage coming out of the motor, and this is the AC current coming out of our system, and this is the AC voltage coming out of our system too. And this is the amount of energy that's going in, and this is the energy that's coming out of our system. And as you can see here, we have a display showing the power being generated at that moment. And this is the amount of energy that's being accumulated so far since the start that she's been biking. So, and now it resets if you hold down the button for 2 seconds.
So for our synchronization algorithm, you can see the results on the oscilloscope here. The yellow channel is the reference signal representing our grid that we generate using the function generator, and then the blue signal is our control signal that goes to our gate drivers. And the control signal we expect it to be all positive and sinusoidal, and basically the way that the gate drivers and the half bridge are set up on our circuit, the output voltage should be in phase with the control signal that we have here. So if the average sinusoidal signal from this control signal is in phase with our reference signal, then our output voltage should also be in phase with our reference signal. So here, if you zoom in, you can see that the duty cycle of the control signal changes depending on the sinusoid to create, if you were to average out the signal, it would create a sinusoidal signal. And then if you were to actually average it out here on the oscilloscope, you can measure the phase difference between the two. And you can see there's approximately a 6-degree difference between the two signals, meaning that we are within our spec of a 20-degree phase difference between the reference and our signal.